number 8 here says find an equation of the tangent function that has two consecutive x-intercepts at negative pi over 4 and pi over 2 and passes through the point blah. So before I actually find an equation for this, at the end of the day I'm looking for something like this, right? A tan dx minus c. This is what the question's asking for. It wants you to find the equation of a tangent function. But before I can jump into that, let me go ahead and draw a picture. So this is something we did back in chapter 6. This is related to graphing. Really, this is reverse engineering from a graph to get the equation. All right, so I'm going to draw a graph first and then try to go back to the equation. So what I know from my problem is that I have two consecutive x-intercepts at negative pi over 4 and pi over 2. So here's negative pi over 4. Here's pi over 4. Here's pi over 2. Two consecutive x-intercepts, so I hit the x-axis here and here. And the point, or the function passes through the point negative pi over 16, negative 3. So negative pi over 16 would be a really small x value. Actually, pi over 16 is going to break pi over 4 into 4 equal parts. Right? 1, 2, 3, 4 pi over 16. So this will be negative pi over 16. And I'm supposed to be down at negative 3. So, what I need to figure out, or I need to figure out a lot of things. I need to figure out the period of the function, the phase shift of the function. Maybe I can figure out the amplitude already. I don't know, it depends. But do you have any idea what this function should look like right now?
Snake.
So a tangent's always a snake, right? This has got to be one period. Why is this one period of my tangent function?
Stereo intercepts.
Because it repeated, right? If you look at the regular tangent graph, the original tangent graph is a snake with asymptotes at pi over 2 and negative pi over 2. Right, where does the next snake have its, where does the next snake start? Well, if you draw out the next asymptote, it'll be at 3 pi over 2, because the period of tangent is pi. So the next snake will be right in the middle, and this guy will be at pi. Right, so every pi, every period, tangent has a new x-intercept. Just like every period, it has an asymptote. So one quick assertion I can make here is that this gives me the period of my tangent function. The visual should be some sort of downward snake, like this. And I don't, excuse me, I don't actually know yet where my asymptote is here. There's nothing in the statement of the problem that says the asymptote has to be at 0. So this is the visual. Now I have to work backward and build my A, B, and C, right? Find out my A, B, and C for my tangent. So what's my period? That's a good place, as good a place as any to start. 3 pi over 4. How'd you get that? Genius, all right. For those of us who are not gifted. You can count it here, right? This is 1 pi over 4, this is 2 pi over 4, this is 3 pi over 4. On top of that, it might be helpful to find the quarter periods, because we know everything at tangent happens in reference to quarter periods. So usually when we're graphing, we find the quarter period. In this case, the quarter period would be 3 pi over 4 divided by 4, which ends up being 1.
3 pi over 16.
Yeah, you flip and multiply, and you get 3 pi over 16. So remember, the way the structure of tangent works is if you go 1/4 period to the right from a 0, you go up to the a value. And if you go 2/4 periods, you get an asymptote. If you go 1/4 period to the left, you go down to negative a. And if you go 2/4 periods to the left, you get an asymptote. So we know our period. We can use our quarter periods actually to figure out a, because I can confirm that if I go from negative pi over 4 to negative pi over 16, how far have I traveled? 3 pi over 16. Right? Because you're thinking of this guy as negative 4 pi over 16. So if you go to the right, you go 3 pi over 16. So what does my a value have to be? Negative 3. It's going to be negative 3 since I went to the right. So I know a from inspection. Can I get b? B will come from the period, so I can solve for b by setting up 3 pi over 4 equals 2 pi over b.
Pi
Oh.
over b.
Oh, that's right. I almost made a fatal mistake. 2 pi over b only works for sine and cosine. This has to be pi over b. Thank you. And if we multiply the b up and the 4 up, 3 pi b equals 4 pi. So b equals 4/3. B, got a. So the only thing left is c. And what is c related to in tangent, or in any graph really? C is related to the new 0, right? C over b tells you where this 0 moves. So one way to do this would be to take c over b and set it equal to negative pi over 4, because that's where your 0 is. All right, when graphing tangent, your new 0 is c over b. So in this particular case, negative pi over 4 should equal c over b. But I know b, because I just calculated it. So negative pi over 4 should be c over 4/3, and then I can solve for c. So I'd have to get rid of the 4/3 here, so multiply by it. That'll cancel out 4/3. So 4/3 times negative pi over 4 is going to be my c value, which is actually equal to negative pi over 3. So the final equation of my function would be negative 3 tan 4/3 x plus, right, you always change the sign for the phase shift, pi over 3. I don't have a process for you to do this problem. I'm sure if you were smarter than me, you could come up with a process. But kind of the point was to see how much you really understood about the graph of tangent, how much of the structure you really internalized. Because you really need to know everything about the structure of tangent to get this.